Anybody? Good. Over here. That's the seminiferous tubule. And these are tails of sperm. All of these are tails of sperm, man. We make millions of sperm. We start out here with a mother cell, spermatogonia they call it, and they mitotically and then meiotically divide as we move to the middle. And they get here, they're immature, and they're going to go off to the epididymis for maturation. We have 4 slides on this final exam, which I'll go through every day with the piece of cake. And 1 model, just 1 model. We just got 1 model left, all right? So pictures on Pluto already. It's probably on Facebook, labeled completely. That's the ovary model. It's reproductive. Funnel is, boy, I don't know how to break it down, but I think about 10% endocrine, probably about 25% genetics, and the rest is reproductive. That's how it's going to lay out, so it's really about reproductive. I've been teaching this for 27 years. I don't get embarrassed anymore, so ask anything you want to know. Now's a good time to ask anything you want to know. If I got an answer for you, I'll give it to you. I've heard quite a few of them. If I don't have an answer for you, I'll look it up. But don't be embarrassed about anything in this class. This is about anatomy and physiology and reproduction. And even though some of you have kids and think you know everything about everything, you'll learn a lot, trust me. You'll learn a lot. What's this?
Sperm.
That is a sperm head that in a tail, which we call a flagellum, penetrating the outer cells of an oocyte. Isn't that beautiful? I mean, how do they get that picture? I know. It's in a petri dish. That artificial in vitro insemination or fertilization happens in a petri dish. You can actually take pictures of it, but the magnification of this is about, that's probably about 10,000 times magnification. So that's an absolutely gorgeous, gorgeous picture. And here's your first slide. That will be probably the easiest slide you'll have in anatomy and physiology. Name these cells. Sperm. They're sperm. All right, they're sperm. How many chromosomes? Now this is where we get back to have some fun. How many chromosomes? These are test questions. We might as well get at it. All right. How many chromosomes does sperm have? 23. 23. All right. They're haploid cells, if you remember that from biobonds. Second slide that'll be on your exam. These are the seminiferous tubules. I know you haven't looked at any of this yet, but you'll get them. Seminiferous tubules are in the testes. We have interstitial cells here that are valuable and important for hormonal release. We've got, and hormones on this exam. If you've had me this year, lucky or not lucky, I don't know, but I've covered hormones all year long. So when we do the endocrine chapter, it's about 10% of this exam, but they're hormones, except for reproductive hormones like progesterone, testosterone, estrogen, prolactin, a few of the other ones. We've covered them all year, and so I have a sheet on Moodle that is just a review sheet. So I'll list out the hormones, and you tell me target tissue, where's it released from, what's the target tissue, and what's it do with the target tissue. And 90% of it you've had this year. So it's just going to be kind of going back to your notes or your textbook and figuring it out. And that's how I'll test you on the endocrine system. So not a lot, but enough that'll make a difference between an A and a B. So let's make sure we cover those hormones. Testosterone is the big one here from the interstitial cells. And then we start out here with the mother cells, and they mitotically divide, and then we go through meiosis. You guys remember meiosis from biobonds? We're gonna have to go back and kind of look at meiosis again, because it's a reduction division where we go from 46 chromosomes into 23 chromosomes, and then you get the immature sperm with the tails as we're heading into the lumen of the seminiferous tubule. So that's organ, testes, structure, seminiferous tubules, and then all of these cells. Anybody know what this is? Thank you, Lindsay. This is the uterine lining. So organ is the uterus. And if we look at the lining of the proliferative phase, the big comfortable sofa for implantation, which is at this phase here, and then the menstrual phase, which is down here, where we actually get a reduction in the uteral lining. So each uterine cycle we actually get a development of the uterine lining getting ready for implantation. If implantation occurs, it will stay in this thickened level throughout pregnancy. But if no implantation occurs, we'll go through and enter the menstrual phase where all of this sloughs off. You'll have to figure out the difference between, there's actually two stages or phases in the women's cycle, 2 cycles. There's the uterine cycle, which is here, and the ovarian cycle, which is complementary, but quite a bit different. So we've got a lot to learn. I think the female physiology is the tough part of this exam. And then, anybody know what organ this is? This is the last slide, so we're looking at 4 slides. Anybody know? Yeah, this is the ovary, and this is the egg, if you will. It's called an oocyte at this stage, but this is about day 12, and so you'll have to look up and figure out, well, if the oocyte is developed to this stage, and we've got this antrum, which is a vesicle full of fluid, we're about ready for ovulation. So you have to tell me on we're going to assume, big assumption, you guys will probably laugh about it, but we're going to assume for the exam that cycles are perfectly 28 days. Right? Starts on day 0, ends on day 28. Everything happens at a certain period of time, which doesn't happen in real life, but we're going to assume that for the exam. So ovulation happens. Anybody know what day ovulation happens in a 28-day cycle? Day 14. Day 14. So we're going to make some assumptions about days on the exam that don't really fit reality, but it's easier to test you on because you guys can all argue. It doesn't always happen on day 5. Yeah, I know. Got it. And so this is uterine lining again. So these slides are taken out Google images as usual. They're on Facebook. You guys can see all that stuff and understand the 4 slides, 1 model for this exam. We good? This is fun stuff. Everybody take a deep breath. This is I know. Stress, end of the year, everything going on. Some of you guys are moving here pretty quick to go off to different schools. And we have 1 test left. This is fun information. Everybody should know it. We'll just kick back. We don't really have any labs or anything left. So I'm going to lecture on reproductive today. Talk more than lecture, but talk to you about reproductive today. We're going to do that again on Monday. We'll start genetics on Monday, and we'll start our genetics problem set on Wednesday with an intro to hormones, and we'll be pretty much done by a week from today. We'll pretty much be done with everything you need to know for the test. So, terms that you should know about: production of gametes, sperm and ovum. Are the gametes, and when I say N plus N, that is the haploid state. You guys remember that from biobonds? Haploid, diploid, or diploid, depending on where your instructor was from. Haploid is 23 chromosomes, and you add 23 plus 23, you get 46. So the gametes have 23 chromosomes. And when a sperm fertilizes an ovum, you'll get 46 total. Always? No, there's some genetic abnormalities we'll learn about next week, like Down syndrome. Down syndrome is 47, 2n equals 47 with a non-disjunction problem, usually chromosome 21. And you get 47, and that's not a normal chromosome number, and so you can get some phenotypic changes with the patient. Primary sex organs: testes and ovaries. Testes, testosterone is the big hormone that is invading and stimulating the testes. Ovaries have estrogens and progesterone. And yes, that is correct. There are multiple estrogen chemicals in our body, male and female, actually. We start with the male system just because the book does, not because I'm male. I'm biased. Just the book puts the male first, so I did too. The process of forming sperm is called spermatogenesis. The testes are an oval organ divided into lobules by a white layer called the tunica albuginea. Albuginea means white, so that's white layer or tunic. Seminiferous are where we develop the sperm. And then we have a ductual system to get out of the testes. Let's go take a look at the anatomy, and then all of this might make a little more sense as you go through. You guys read the paper yesterday? First transplanted penis?
Yeah.
Fascinating. Cancer patient had genital, I think, removed due to cancer and had a penile implantation transplant yesterday, first one in history. If you can imagine the blood vessels and nerves that have to be hooked up for that to be functional, that's unreal, unreal. First time ever. So here's the male system. You're all like, yeah, I know all this. Now, you don't. Let's learn it. Here's the testes, all right, testes. How many testes are there? Two, all right, two. Not always. Testes for males actually are embryologically developing up in the abdomen, and they shift down through the inguinal canal, usually before birth. And so one of the first things a physician will check with a newborn male is if the testes have descended properly into the scrotal sac. If they don't, one of them might stay, or both might stay in the abdominal cavity where sperm development will not happen, and they have to be surgically pulled down into the scrotum. When they're not set normally, whether you have one or two that are undescended or undescended testes, it's called cryptorchidism. You guys ever heard of that? Orchid? All right, orchid, so that's cryptorchidism. So they settle there. Scrotal pouch out here, outside of the abdominal cavity. You may know why? Doesn't seem like a very good place. Yeah, temperature, all right. Sperm development need to be in a cooler environment than the abdomen. And so they actually drop them and descend them out into the scrotal pouch where it's usually 1 to 2 degrees cooler down there unless you're wearing tighty whities. That can elevate the temperature. Back in the 80s, early 80s, late 70s, a lot of males were infertile. They didn't have a sperm count that was high enough, and it's because they were wearing tight jean shorts and tighty whities and sitting in hot tubs all the time and smoking pot. And because of all those things, it lowers your sperm count. And so they just said, don't sit in hot tub, don't wear tight clothing, and all of a sudden the sperm count came back up. It is pigmented. The scrotal pouch is pigmented. It has some hair on it. Hair is always for protection in our system. They think it's for things to glance off of it, but it's pigmented so that if you are outside in naked sunbathing, or back in the day when clothing wasn't worn, it's pigmented. Will protect the developing testes from UV radiation. So the testes is wherever the sperm are actually formed. Then they come here into what I call Gold's Gym. That's the epididymis, and they usually take about 20 days to go through the epididymis, and they have to go through there to be mature. All right, it takes a little bit of time for development of sperm, and we're talking millions, millions and millions and millions. Anybody know how many sperm are in one ejaculate? One ejaculate?
200, 300.
Yeah. 300 million is a good number. 300 million in one ejaculate. So do we make a lot of sperm? Lots of sperm, lots of sperm. It comes in here, and once peristalsis, peristalsis, have we heard that before? Yeah, old term. Peristalsis actually occurs neuronally along this pathway, and the epididymis starts squeezing, and it squeezes the sperm into this tube. And this tube system is called the vas deferens or the ductus deferens. You ever heard of that? All right, and that sperm is being carried. And as we come along with the sperm, we'll then start adding seminal fluid to it from seminal vesicles. Here's a singular prostate gland. You guys ever wonder where the prostate gland was? If you did, there it is. It's a singular gland here. Many males at a certain age have rectal or digital palpation of the prostate, so they actually go through the anus and actually feel the prostate gland here, and if it's a little bit swollen, enlarged, or hardened, then they actually will do the PSA test, which is a prostate-specific antigen test, to check for prostate cancer, which is usually they say, I don't know what the commercial says on TV, that must be right, I can use that number, but 1 in 6 males will probably get prostate cancer in their lifetime. And so there's the prostate gland right there. And then we also have this vulvourethral gland, which is the pre-ejaculate, which cleans this too, because in the male system, sperm is following the same pathway as urine. And as we now know, is that a little bit acidic? Mm-hmm. Yeah, and sperm don't do very well in acidic environments. So we actually have a pre-ejaculate little gland called the vulvourethral gland that will eject a clear fluid and clean out the tube before the sperm actually gets through. So anatomically, you'll have to understand the vas deferens, seminal vesicles, ductus, prostate gland, bulbourethral gland, and how they all come together in the exiting tube, which is called the urethra. Does that make sense to you guys? All right, so the anatomy, follow the pathway of where sperm, be a sperm, all right? So I'm in the testes, and now I'm in Gold's Gym, and then follow the pathway all the way through. Tell me all the things you see as you go along. Significance of the vas deferens. Vasectomy. There's where a vasectomy takes place, because they actually come in through this spot right here, and they will either snip or cauterize or both this tube. And so they ask very unique questions at the urologist about married, divorced, want to have more kids, think you might want to have more kids, blah, all these different, and based on your answers, they will either sever and cauterize, which makes a pretty permanent vasectomy, or they will actually just snip and tie, which will actually, if you ever wanted to go back in and have a reverse vasectomy, that would be more likely to be okay at that point if you do it that way. So that's where they go in right there, and they snip that tube, and if you snip that tube, sperm cannot get out of the testes and will not be released in semen. Is there still ejaculate after a vasectomy? Sure, there's just no sperm in it. So the fluid is there, but there's no sperm in it. That's the male system. Pretty simple. New terms. Here's how all the hardware is set up. Anything in blue up here is what we call erectile tissue. Erectile tissue actually floods with blood on excitation and will contribute to an erection. Viagra and some of the new medications that are on the market now are targeting vasodilation of these vessels and vasoconstriction of the vessels exiting the penis. And so all the blood gets trapped, and that's how erections are stimulated. Question? You guys are deadly quiet today. Don't be. Nothing to be embarrassed about. Scrotum. Skin-covered pouch surrounding testes. Two muscle groups important for the scrotum: dartos tunic and cremaster muscle. These are muscles that will draw the testes closer to the abdomen or relax and move the testes away from the abdomen, and that is in thermal regulation. All right, so anybody ever seen that Seinfeld episode where George dives into the ocean and he comes out and he's changing back in the house there? I think they're up in the Hamptons, and you guys know what I'm talking about?
Shrinkage.
Okay, all right, I don't know. Anyway, his genitals are shrunken, and he blames it on the cold ocean. Well, there is something to that. If you dive into a cold lake as a male, you're actually, these muscle groups contract and will draw the testes closer to the abdomen to try to maintain a normal heat for sperm development. The opposite is true, is if you're very warm or hot, a hot tub or out where the heat is, these muscle groups will relax and the testes will be allowed to descend away from the abdomen to maintain thermal temperature for sperm development. Shrinkage, I think, is what George called it. Funny. Epididymis, this is Gold's Gym. All right, this is where the sperm, after the sperm are made, they've got a tail. They have no idea what they're doing. They don't know how to swim. They're not mature. So they go to the epididymis, Gold's Gym, about 20 days. This is where they mature, gain motility. And it's surrounded by smooth muscle that begins the peristaltic contraction and will move that sperm into the vas deferens on ejaculation. So what if it doesn't take 20 days? What if a couple is highly sexually active? Are the sperm going to be mature? There's that old story, a couple is, they're trying to have a baby, they try for 6 to 8 months, they finally go to the doctor and say, hey doc, we've been trying for 6 or 8 months, we're not able to have, and the doctor says, well, how many times do you have sex? And they said, 3 times a day. The doctor says, stop, you got no sperm that are mature. So even if they're deposited in the vagina, they have no idea what to do when they get there. And so all you have to do is wait 14 days for some mature sperm to be in the ejaculate, and then fertilization is much more likely. Ductus deferens, it's the vas deferens, it sends over the bladder, enlarges into an ampulla, joined by the seminal vesicle, and becomes the ejaculatory duct. You need to know numbers as you go through. So how many testes are there? Two. How many ductus deferens are there? That's where we get into. There's two. All right. Prostate? One. All right. Scrotum? One. It's just the pouch is the scrotum. All right. So figure out your numbers for these, so you'll actually start figuring some stuff out. Seminal vesicles, there's two. Vasectomy cauterizes the ductus deferens or the vas deferens. Seminal vesicles add fluid to the sperm. But we're finally starting to make, if you look at the term seminal, semen. That's where semen came from. Semen is the fluid, has sperm in it, adds seminal fluid to the sperm. So really what we're sending up from the testes is just sperm, swimming sperm. And when it gets to seminal vesicles, we start adding fluid to it to form the ejaculate. Fluid has, so the sperm have been swimming, testes, 20 days in the epididymis, now they're in the vas deferens, they're going over the bladder, and they hit the seminal vesicles, and there's some fructose there. What's that for? Cafeteria. Fructose is sugar. Sperm are hungry. They've been gone 20 days on this journey. They finally hit the mother load when they hit the seminal fluid because they've got fructose there and prostaglandins, which are chemicals that will affect the vagina and the uterine cervical mucus when the ejaculate is deposited. So these prostaglandins decrease the viscosity of the cervical mucus, and they cause reverse peristalsis of the uterus. Is this important? What's the goal? What's the goal of the reproductive system? Fertilization. That's it. All right. May not be your goal, but that is the goal. So everything around this is looking at getting the sperm toward the ovum in the fallopian tube or the oviduct. Are we clear on that? All right. That's the goal. So anything in this is going to help aid sperm in their journey to find the ovum. Prostate gland, singular, and we also add seminal fluid from the prostate, and it has enzymes in it, which will activate the sperm. Bulbourethral gland I told you about earlier, adds semen below the prostate. It's the first release into the urethra, which is the pre-ejaculate, if you want to write that off to the side. That's what cleans the urethra. And then the penis, which is used for depositing sperm in the vagina, is erectile tissue. And there are three areas of erectile tissue, two corpora cavernosa and one corpora spongiosum. Those are the erectile tissue of the penis. What is semen? 300 to 600 million sperm in an ejaculation. Are you guys figuring this out? 300 to 600 million sperm in one ejaculate. Ejaculate usually has 3 to 5 milliliters of fluid in it, but there's an enormous amount of sperm. How many does it take to fertilize the ovum? Yeah, 20. Yeah, we're changing the way what we understand. First one that shows up, here's what happens. This is a great system. I don't know, 21, whatever you want to call it. I don't care. But when you get to the egg, the secondary oocyte, it's surrounded by cells, follicular cells, and the first sperm that gets there says, "Woo, made it." Well, it's got a little cap on it. This cap is called an acrosome. You guys ever heard of that? It's a little cap that's full of enzymes. And so it's going to hit this wall, and it's going to release its enzymes, and it's going to make a dent. But that sperm doesn't get in. Next sperm comes. It releases, breaks its acrosomal cap, releases enzyme. It makes a little dent. And so, how many dents do we need to do to get inside and finally get that bad boy in there, it usually takes about 20 hits before one sperm gets in for fertilization, all right? So the first one there, the fastest sperm, is that the male or the female sperm, the fastest sperm? Is there such a thing? This is fun stuff. There is fast sperm, super fast. They come right out of the gate. Sperm look like this. Well, I don't know. You guys are used to my bad drawings now. Do you see that that's a little bit bigger? That sperm here is a little bit bigger with the head. Does that make sense to you? A little bit? All right, give me that. The one that's carrying the Y chromosome is a little bit smaller because the Y is a little fragment chromosome. The one that carries the X is a little bit larger. Which one's faster? That one. That one's the fastest, all right? Because it's not carrying as much chromosomal material. So the Y actually can swim the fastest and might get there. Problem is, there's no egg. Let's say it gets there, runs the gauntlet through the vagina and through the cervix, up through the uterus. It's got two choices, go right or left. Let's go right. And he's headed out toward the ovary and the fallopian tube. And he gets there and there's no egg. Yeah. But a day later, egg shows up. The egg was ovulated overnight. And now the eggs can fertilize. So it's really interesting. These are the fast ones. The ones carrying the X. These are a little more slow, but they're a little more durable, and they can get there. It totally depends on ovulation. Can you track your ovulation as a female? Absolutely, track your ovulation. So is there a way to predict or, sex of your child? Yeah, you can bust the odds a little bit by knowing when ovulation takes place and when you should actually deposit the sperm. Based on the ovulation date, whether you want a male or a female. And just as soon as I say that, and that's what you try, you go online, you can predicting the sex of your child. There's tons of articles on it. They say it's about 80% effective, but as soon as you try it and you wanted a boy, you'll get a girl. It's just the way it happens. Okay.
So if it only takes about 20 sperm to do enough dents into the ovum, and it takes a day later for the X spermatozoa to show up.
Yep.
Why do we have women around then?
How did that happen? I'm going to rephrase that question. The idea is that let's say I get your point. We all get his point. Here is the uterus, vagina, and the oviducts. And down at the end of the oviducts, we have this thing called fimbriae, and there's the ovary itself. And so sperm are deposited in the vagina. They swim through here. Let's say the fast ones get out here, and there's 20 of them, but the ovary hasn't ovulated yet. They're going to actually be reabsorbed in the female system. All right. So the ones that were going to create a baby boy, they show up and the party hasn't started yet. And then 12 hours, 18 hours later, the ovary ovulates, and now we've got a egg here. And the ones that have been a little bit slower to the party show up, and now they can fertilize. So there'll be 20 of these, but these will all be carrying, this is a day later or something like that, they'll all be carrying the X chromosome now. And it's completely about timing of the ovulation of the ovum and when the sperm were deposited. And so people do try to predict that as the temperature, basal metabolic temperatures are changing in a female's system, that I'm about to ovulate. So if you want a boy, now's the time to deposit the sperm, and the fast ones will get there first. If you know that, ovulation just occurred, now it's a good time to actually deposit the sperm, because they'll show up in a day or so later. See how that makes sense? Yeah. Does that make sense to you guys? Timing, fun stuff. Semen is slightly alkaline because the vagina is acidic, and we want to balance that. Sperm do well at a pH of 7. So the seminal fluid itself balances the acidity of the vagina. There's some chemicals in semen like seminal plasmin, which will reduce the cervical mucus thickness. There's fibrinolysin that breaks up the semen clot. When semen is deposited in the vagina, it's a big clot. How many are deposited again? So in an ejaculate, there is 300 to 600 million sperm in an ejaculate. But because the acidity of the vagina is so high, about all of these get killed just on deposition in the acidic vagina. And what we're left with is this little clot of sperm that is still alive, that wasn't affected by the acidity as everything else around it was killed. And then this clot of living cells then is released by fibrinolysin, and then it allows, in essence, the clot opens up, and now these little swimmers can start their journey. All right, so an enormous number of our 500 million sperm deposited in the vagina are killed immediately on deposition. And what we're left with is a small protected group that then opens up. This opens up in about 30 minutes after ejaculation. Questions on that? Male simple, pretty simple stuff. All right, all right.
So how does the day after pill work?
Day after pill makes, there's several of them now. You guys should, I don't talk about contraception in here, but you guys should all be, if you're interested, the internet's a beautiful thing now, but a morning after pill doesn't allow for implantation. So it makes the most of them. There's a lot of them. So the ones that are most common make the uterine lining inhospitable for implantation. So fertilization might have occurred, but implantation in the uterine lining will not, generally. And it will slough off that tissue to prevent any implantation. Does not prevent fertilization. Good. Anything else? Those are all good. All good. There is a section there, technically, if you want to list about contraceptive. The pill has been around for, actually, the company that I work for in Palo Alto, San Francisco area, originally started, the pharmaceutical company originally started and made the first birth control pill in 1958. That's where they made all their money, and that's where they went off into a different line. You know where they discovered the birth control medication? Jungles of South America. Plants. Where are most drugs derived from? Plants. And so they actually found this rare plant down in South America in 1956. That plant had a chemical in it, and that chemical was called progesterone. You guys ever heard of it? Isn't that amazing? Man, that's what, 50, 60 years ago. They found, then they started, when the original birth control pills were awful, 100 times the dose that was necessary for stopping or preventing ovulation from occurring. And they become better and better and better. Yeah?
Rodents actually had a plant a lot like that too. And the rodents had a plant a lot like that too. That's actually why we have the leaves were heart-shaped. That's why we have Valentine's Day heart-shaped leaves.
You're kidding me. I've never heard that story.
Yeah.
No kidding. Yeah?
It was actually so popular that it's now extinct.
Fascinating. So the plant's gone.
Yeah, oh yeah.
Now just harvested along the rivers and no, that's fascinating. Well, we have this, it was Sunday. Dang it, should have announced that to you guys. We have a great wildflower show over at Mount Pisgah that our botany students put on. And great, all native flowers, Oregon. But the nice thing about it from our standpoint is that they will actually put a little blurb underneath the plant about pharmacological properties. And so a lot of these plants that if you were living in the woods or 100, 200 years ago, you couldn't go to a pharmacy. You don't know how, I don't know if people appreciate it. I spent 3 weeks of my life in mainland China, not Hong Kong, mainland China. And I came back going, man, we are so lucky here. We have no idea, but you don't get that experience unless you travel. And so 200 years ago, there wasn't Walgreens. You know, you get something, the doctor says, yeah, I'll call it in, what's your pharmacy, you go pick it up, you get your, well, in the old days, where would you go find your
medication, if you had, disruption in your digestive system or something like that, you go eat a plant. You go find a plant along a river, and that's the one that, you know, there's something that we eat commonly now that helps with digestion. It's called ginger. You guys know what that is? It's a plant. And so all of these things were used commonly 200 years ago, is that you didn't have pharmacy, but you go find a tree or a twig to chew on, or a plant, and that's just how you got rid of headaches, and how you did different things. So, plants is where, that's an interesting story. I'm gonna look that up, Michael. Plants is where most pharmacological agents come from. Good. How we doing? Why don't we take a break? This is pretty much